So, Prem, it's visible now?
Yes, Professor.
Okay, thanks. So, it's the 15th lecture, and the focus of the lecture is to discuss the file system organization, directory structure, and the concept of file sharing. And it's the first part, so we'll discuss all these components in brief. And specifically, we are going to emphasize more on file system organization because it is the core component that is supposed to have the other components like process management and kind of your other file components. So those are needed while storing a file. So when you store files, so definitely comes the another component that is storage management. And then when you have the kind of input output with the devices, so device management comes into picture. So file management and it's a storage inside system. It's a very good topic to discuss about. And from a critical point of view, also it's very important. So specifically the objectives are that we are going to discuss the different types, the virtual file system, different allocation methods means as we already have discussed about that how to allocate the processes inside systems. So similarly, we can say because ultimately processes are what? Processes are the kind of programs only. So here we are going to discuss that how specifically those programs are supposed to get stored inside your memory means in your disk memory because for permanent storage if you want to go for then you can't choose RAM. So because of its volatile nature you are bounded to have the third party storage or the kind of secondary storage. And obviously disk is the most profound secondary storage that is used for storage purposes. So here the second focus is of directory structures, and again we are going to discuss different types and respective analysis. Finally, we'll discuss a brief notion of file sharing and what, why, and then three typical questions, and respectively that what are the different roles of file sharing in different environments. And in the last, we are going to exchange a few words in terms of discussion. Moving forward, I'm going to have the concept of a file system with a very basic question that it's a method of organizing files. Normally, we know that file system is a kind of that we are whenever we are supposed to organize or whenever we are supposed to store something inside our system, then we are supposed to have a kind of system where means everything is present inside your system. So, but when you store them, then their organization is a kind of a bit different storage than your normal system storage. Because a normal system storage, what I'm trying to say that when we store something in a normal fashion, then people do have a notion that, oh, means this is supposed to get stored like this. But user view is always different. As we have already discussed the concept of user view while we discussed the concept of segmentation. Because user view is very important because in any system, user is the sole proprietor. Sole proprietor means we are not saying in the sense that he has the command over all the things. He is the kind of administrator. No, but ultimately, why everything is getting developed? Why your database administrators, your system management, and all kind of component means all these component development teams and your management teams are working for whom? They are working ultimately for users only. So if you don't get the user satisfaction, if you don't comply with their opinion and their views, then ultimately your development is of no use. Okay, so that's why user's view is a very important thing, and you are supposed to adhere all the kind of characteristics or qualities those are supposed to get incorporated inside a user view. Okay, so here when we are discussing the concept of file system, then also we are supposed to maintain that user's view because ultimately that user is very important and he will always imagine that, oh, file is supposed to get used or stored inside a system like this. So you should be close to that view means try as much as possible to be proximate to that particular user view so that ultimately user doesn't find any kind of difference in his thinking and in actual realization. Because for example, somebody is imagining, oh, this is the word and it is supposed to look like this, but in actual implementation if you show him totally opposite kind of scenario, then he'll totally get into a kind of dilemma. Oh, my opinion was this, but it is totally different. So there will be kind of clashes of two opinions. inside his mind. Okay, so that shouldn't be the case, because if you become closer to the user's perception, then ultimately users feel good, and that feeling is more important, because that kind of positive vibes, those give kind of motivation to the users to learn more, to delve into the subject more, to invest more, and ultimately to purchase more products from the same companies, kind of thing. Okay, so here, in addition to this, it is not always the case that you are supposed to only worry about the user's view only, means not about only the presentation. From efficiency point of view, you are supposed to work. So file system are supposed to be closer to the user's view, but as well as you are supposed to maintain the kind of efficiency those are very necessary for the actual file system implementation inside a system. So when you store a file, normally we define in a very layman term that it is what? It is nothing. A system of storing files is file system. Okay. So the another question comes that, okay, if you are saying like this, then what is the actual importance? Means if it is just storing the file, then we are storing files everywhere. We are storing files in RAM also. That is, though it is logical space, but still we are storing. Okay. But then you are supposed to counter that, yes, we are storing in RAM also, but we are supposed to store in disk. Why? Because of volatile nature of your RAM. You are not supposed to have those files after a while. So that's why there is no guarantee of having consistent storage inside RAM. So that's why not to move to a kind of consistent and long-term storage, so that you could easily copy things, share things, and different users could gain access to those files. So second question comes that where is the actual space then? So the actual space is on physical media, and that physical media comes in the form of secondary storages, might be the hard disk, CDs, flash drives, or the any third-party storage. Okay. Now we are supposed to have a different kind of operating system. So this concept of storage as well as this concept of file system implementation might vary from OS to OS. So that's why in Windows users are presented with different choices. Okay, you must have heard of the FAT file allocation table and the NTFS file systems. Okay, so these type of new type file systems and all other file systems, so those are very much recommended for new users. Okay, so in different new versions, so those come according to time and will come over the period of time. All those operating systems have their default operating system, their default file system according to the underlying operating systems. But yes, you always have the liberty to choose a different kind of file system if you are so much aware about all the characteristics and the underlying differences between different file systems. So those are present on that particular OS. Okay. Now, if you are familiar with the basic characteristics, then you can easily judge, because there is always a fixed criteria, kind of criterion that will help you to judge the properties that whether in a particular context or environment that particular file system is suitable or not. Okay, so these kind of things you have to means a judge, you have to analyze, and then you need to make a decision. Ultimately, when you come on to a single decision, then you can decide all the things. So moving forward, what is the criteria? We have discussed that user is free to decide a kind of file system choice, but on what? Means what is the basic criterion? So it will depend on the type of media involved, because when we are saying that a particular file system is good for a particular kind of machine, then obviously it is not always the choice of a file system as well as just your machine. It is also dependent on the kind of media, means what kind of content you are supposed to store. And with respect to different contents, there might be different means for if you are supposed to have video files or something, then you are supposed to have a kind of large storage space, because video files is supposed to take more storage spaces than in comparison to non-multimedia kind of things. Like if you have the plain alphanumeric character based files or simple numerical data files, then those files are supposed to take much less data in storage space in comparison to your multimedia or the kind of bimedia kind of files. So in this way, when we say that different kind of things, different kind of options you do have inside your system, but always the choice, and normally we always go with the kind of default systems only, and it is obvious choice also, because people do know, the system developers do know very well that the layman users, a common user doesn't have this kind of familiarity of your machine and OS and the file system and the kind of processes So why not to give a default option? So every device driver, every your system utility, your DLL files, or kind of any exe you will talk about, that has a kind of default recommended setting. Okay, you go with that particular setting, and obviously that is going to help you for your long-term decisions. So those are supposed to take place, because ultimately you will store the software once, but ultimately every time you'll run it, you'll work with that particular kind of software. Then all your settings, those are supposed to get remembered by the recommended setting tab. Those are supposed to get utilized. Okay, so you can have the option of custom, but yes, you should be knowledgeable enough to choose the kind of custom settings. Same thing stands true with your file system choice also. Okay, so moving forward, we are going to discuss the different file systems inside Windows. So these are some of the NTFS and FAT, two most popular operating file system choices. Okay, so when we discuss the new technology file system, then it's means many people do call it a new type file system also. Okay, but new type file system is a kind of it is actually a new technology, and a new type means it is a kind of bit different from FAT. And FAT was the kind of very basic file system that was developed for specifically your multimedia Windows OSs. Okay, and initially it was quite popular, and still means today also many people use FAT file system because of its simplicity only. Okay, and it is compatible with most of the operating systems from Windows side. Those are available in market, and in addition to Windows, it is also compatible with your other machine types also. Okay, so on your Mac, your Linux-based systems also, you can work with FAT. So when we say that we are supposed to choose a particular file system, then this file system is supposed to take care of your file storage inside your system. That how to store a file, what kind of pointers you are supposed to maintain, what kind of data structure are supposed to get incorporated inside system. Then those data structures are supposed to take care of your underlying processes, storage for long term, for short term, over the period of time, how to move from one buffer to another, from one buffer to another file system. Okay, so all this swap in, swap out, all these things are supposed to taken care by your file system, which will work under the control of operating system, and operating system then again a choice of user. Okay, so simplistic structure, and due to its simplistic structure, obviously some of the kind of issues that we normally see means in every system, if it is simple, there will be some issues, because simple things can't handle the complex kind of scenarios. So that's why the issues of over fragmentation and the kind of limitations, those are supposed to get put on your file naming systems and other things. Those things do present in file allocation table file system also. Okay, and to overcome these kind of things, your NTFS came into existence, and it's a very well formed file system, and now it has become a kind of de facto standard for your Windows operating system. Yes, it is a kind of a bit complex in comparison to FAT, and that's why it's a feature rich, because if you don't incorporate much features, then how you'll claim that your system is kind of more complex? Because if you are increasing complexity but not incorporating some good features, then it is a kind of a double penalty, because complexity has more, but still there is no new feature. Okay, so that is very uncommon, because every new version of same software or the revised version of different softwares do come into the market having a kind of different functionality. So that is true with these kind of file systems also. Okay, now we will discuss the other component, that is okay, the common file systems. So the other common file systems, not two. Here it's a mistake. Here the other common, most common file systems. These are the other common file systems. That is exFAT, HFS plus, and the EXT. So that is the extension. So it's obviously for kernel choice, and it is not used for Windows. Normally for Windows we have the NTFS. Okay, that particular first line I forgot to change. Okay, so it's not true here. So the other choices are the extended file allocation table. So it's a Microsoft file system. But the last one, EXT, okay, it's a kind of default choice for Linux-based systems. So it is not popularly available in Windows. Okay, so this first line, that is the two most common file system, it is means kind of same from the last slide, so that's why it's a mistake. Okay, so here these are the other choices, some are available in Windows, some are not. Okay, and again it will depend on your system, because which particular new version is supposed to incorporate means what type of file system inside your system. So whenever you are supposed to have a kind of choice, you always look for a specific operating system, and then you have kind of available choices that you can have inside your particular operating system in terms of file systems. So it is not necessary that you always have only single choice. Obviously there will be 2 or 3 minimum. Okay, but how many choices and what type of choices, it will depend again on your system, means your device manufacturer. That device manufacturer will obviously incorporate some system designer. That system designer will take care of these kind of choices, that what sort of means how many bits inside a system, then what type of your storage devices, then what is the your bus length, and then what type of access control mechanisms, so what kind of file storage mechanisms, and all these process control, memory control, then your device management, and all operating system related issues are supposed to be taken care by your kind of Windows or the underlying OS team. So that OS, because we are incorporating, means we are studying this subject from a general notion. So in a common point of view, if we are trying to incorporate the concept of file system, then file system, why we usually not discuss the concept of file system? The reason is because file is a kind of concept that is not much related with your user's performance view. Performance view is important, and performance is another thing, means that is also important. Performance view means if I normally ask you, okay, that what are the different components those affect a system's performance, what is your answer? Anybody? Tell me 2-3 most important factors which affect a system's performance. Am I audible?
Yes, Professor. The hardware capabilities.
Hardware capabilities. Okay, fine. Other things? Anyone else? Okay, fine, no issue. So why am I asking this question? Because though we are discussing this concept here of file system, okay, still most of you will not consider file as a particular criteria or the factor that is supposed to impact your system's performance adversely or in a positive way, because people do not understand the importance of file system normally, and that's why they never take into consideration that file system is also a kind of choice of critical importance. Okay, so if I ask you, then obviously people will go for the hardware choices, as you told very well. Yes, but that hardware choices are supposed to be kind of constant. Means once you have decided your hardware, is it going to get different for your different OS? No, you don't change a hardware frequently, you change your OS choices. Okay, or you do change your device driver choices, you do change your kind of peripherals. Okay, but you never change your underlying core hardware, because it's costly. Simple reason. I'll not delve into other choices that you have purchased, good or bad, but once you have purchased, you are not going to change it frequently. Okay, and because of its cost choice only, cost factor only, you are supposed to change your software components frequently, because most of them might be free source, and that's why you are don't need to spend a single penny, and you are just incorporate other kind of software, and then you again check your performance. So we try to improve our performance through multitude of kind of software. So those are available in free market or in paid market, and then you try to incorporate to improve or boost your system's performance. But ultimately we do know that our hardware is limited, and it is supposed to give this much at max, okay, in terms of performance. So when we say that users view in performance and actual performance, these things are two different things. Like users view might get impacted, means from different kind of graphs, charts, or the kind of presentations those are supposed to get put in front of him while purchasing or putting some kind of proposal of acceptance or whatsoever. Okay, so the most simple example is this. Okay, you went into a shop, okay, and you asked for a high performance system. Okay, simple choice. Everyone goes like this only. Give me a very good high configuration, good system. Okay, sir, what's your range? My range is 30K or 40K. Okay, sir, in this range, we can't offer you a high grade system. Okay, then let me increase it. It's 60K. Okay, sir, in this, what do you want? I want graphics, a dedicated hardware for graphics, and then I need this much SSD and kind of, okay, stop, sir. You don't have the sufficient budget for these kind of system. You at least have to raise up to 80 or 90 or 1L. Oh, sir, but in that particular, then means am I supposed to have all kind of these SSD dedicated hardware for my graphics and kind of other accessories, and there are some of the paid softwares available in this particular kind of offer. All this means this conversation is going on between the shop owner and the kind of user went for a particular choice. So when we discuss this kind of scenario, then obviously what means how the user's view is getting controlled by the shop owner, you can easily visualize. Whenever a person is trying to make a choice, the other person who is offering the choices is going to impact or control the user's view. Ultimately, he is telling the user that, sir, it is the reality, and believe it, it is the real. So first thing, there are only two cases. Is your user knowledgeable enough to judge all kind of choices those are supposed to be in front of him? And if he or she is not, then obviously the only choice is just believe the proposals. So those are in front of you. So you will change your perception very quickly. And that's why many times we make drastic choices in kind of because a kind of pressure also that no, within hour I need to decide my choice, and then today only I will purchase the system. I have to make a decision today only. So these kind of different factors, or there are certain other limitations. So user's view is highly impacted by the kind of context or the environment that is surrounding the user. So in this way, the perception is also the kind of same thing. Whatever is user seeing inside a system, when you are seeing a particular system, then you look into the system settings, then you come across some kind of CPU utilization graphs, memory consumption graphs, and then other input output performance. Okay, similarly, another well-known example is that when you look for, means your internet is not working fine. Okay, your streaming is lagging. So then you check your downloading speed normally. So what kind of software you are using, utility you are using for downloading, checking. Okay, and what kind of factors, means kind of characteristics that you are looking for while going for a specific analysis of your downloading limit or speed. Then all these things will impact your perception again. Okay, suppose your utility that you are using for a particular download checking, that is not good enough, of not standard. Okay, then ultimately it might be showing you something raw statistics, very common statistics, and not of real time, might be of the day or the average of the day or the last day. Okay, but that statistics is coming from a particular software side, so that's why you are supposed to believe it, because you don't have the better expertise than that particular software, or you are not supposed to judge whether this software is good enough or not, that is offering me all these statistics. Okay, so in this way, user's view is highly compromised, and because of the underlying complexity, the surroundings and the environment, it's common also. So here, whenever we make the choices in terms of file systems also, our choices depend on our context and the network, means the surroundings. Means if we don't have any knowledgeable person around us, then we again go for the same trap. Then we use some, okay, today I'll try this. Okay, but as you do know that file system choices you can't change frequently. Once you have installed your OS, okay, once you have done that kind of choice inside your machine, then again you are not going to frequently change it, because most of your files are supposed to get stored like that only. It's once done. So how frequently you can change your decisions again? This criteria will come into picture, and again you need to think about whether should I make this particular choice at this moment of time or not, because later I can't change it. So incorporating all these kind of different thinkings and concepts, you are supposed to go for a particular decision. So we had discussed these two most popular with respect to Windows, and there are these some other popular file system choices. But again, you need to make a decision whenever you are going for a specific choice. Other common example is then when you format a particular pen drive. Okay, when you put into it will show you a warning that all the contents is supposed to get erased. Okay, it will again kind of a pop-up will come up there, and it will show you that what kind of file system you are supposed to put on your flash drive. Okay, so whatever files you are supposed to store on that particular drive, those are supposed to get stored with respect to that particular file system. Okay, so ultimately the file fetching, its access, modification, insertion, deletion, all these components are supposed to get impacted, and ultimately your memory management, because fragmentation. Okay, again, if more fragmentation, you need to incorporate the kind of techniques for compaction. So all these things means the more fragmentation, less efficient use of memory, need to incorporate compaction, more complexity, and more burden on OS. So all these factors will impact your performance adversely. Hope you are understanding what I'm talking about. Okay, so if it's making sense, then you can easily imagine that how important a particular file system becomes for a particular system performance. And that's why you are supposed to think about these things in depth, that yes, if we are going for a specific choice or a particular kind of software installation choice, then how it is or how it can impact in future. Okay, so if you don't have that kind of right kind of knowledge, never go for any custom installation, always go with recommended ones. Okay, so these are exFAT means again Microsoft file system compatible with your Windows and the OS machines, Mac OS machines, and other multimedia devices are also compatible with it. Then HFS Plus, it is developed by Apple for Mac OS, and then your ext, that is well known for Linux systems, and most popularly your extension 4, ext4 is a popular example of ext. So if you have installed Linux OS in your machine, then you must have come across this word ext4 or ext3. Then file system organization means how to organize different files. So when we say that different files are organized inside a system, then how those are supposed to look like, how those are supposed to get stored inside your memory. So your file system decides that how your files are supposed to get stored in an efficient fashion so that your access doesn't take much time. And what a particular file system is supposed to offer, it is supposed to offer the good interface to your memory, and the good interface to access means the kind of, when I am mentioning this term interface, again it is contextual to theory side, but when you come into the practical side, this interface word is kind of equivalent to your APIs. Okay, means kind of input output APIs is a kind of interface. Okay, then mapping means you are supposed to map your logical addresses with your physical addresses, and the efficient choices, those are supposed to come in this memory access context, because whenever you are discussing a memory concept and the process concept, obviously the efficient access that becomes of profound importance. So you need to discuss that how profoundly, how easily you can fetch contents from your memory, how easily you can write back onto the disk, and all this efficiency will improve your performance and ultimately will result in easy data retrieval. Then we will have a concept of layered file system. The layered file system means it's a file system only, but the only difference that here, like in computer networks or in OS also, we do normally have a kind of layered architecture. You must have heard this concept of a layered architecture somewhere. Definitely not in this subject, but in some subject definitely you must have heard of. Okay, so again one question of a general notion that why do we maintain a layered structure? Is there any specific benefit? You guys must have heard of software engineering practices also. Okay, so there is a concept of waterfall model. So why do we maintain this waterfall or the kind of layered kind of structures? Is there any specific benefit?
Does it help with some kind of like organizing, optimization or something?
Yes, optimization of organization. True, very true. Okay, and when you have the optimization of organization, then obviously you are supposed to maintain things in a better way. So obviously you can look into the things in an optimized fashion, and you can get back access in an efficient way. So ultimately the performance is going to get improved because your response time is less or the search time is less. Okay. So in the same fashion, from again now this definition is from a kind of technical person side, but from a layman person means how we are supposed to discuss. So when we say that we are making layers, then again it's of good visualization. Okay, it is going to put a good impact onto user. Additionally, it is supposed to be kind of easy from an understanding point of view. If I show this diagram, as you can see, okay, layered file system concept is shown here. So if I don't show this and directly just to show you the internal picture of some file system, okay, then a layman will get kind of confusion. Whole lot of confusion will be there because so many APIs will be there, so many pointers, so many different processes, then their process control blocks, then the associated memories, then some of the dangling pointers, and all these things will be present inside a file system. But if I show him only these components, 4-5 components, that sir, first thing is the application programs, then there is a logical file system, then file system organization module, and then there is a basic file system. And then there is IO control, and then there is a devices. So here comes to a basic notion of understanding that between application programs, means my programs, and the actual hardware, there is a layer of system. There is a system of layers, and that particular system is having 4 different layers. Okay, first at logical level, where all the things are supposed to get handled in virtual space. Then file organization module that will take care of how to organize the files. Then basic file system that is close to your hardware, and then some specific input output control, because ultimately file read or write will take place only with the help of some peripheral, means kind of input output devices. So it's easy to have a notion of understanding for a layman in comparison to of showing him that sir, it is the whole lot complex structure of underlying memory, and now you can examine. So in this way, layered file system is always maintained to have a first basic thumb rule, that simplicity. If your system is simple, if your understanding, if your explanation or kind of examples, if anything is simple, it is easy to grasp. And if it is easy to grasp, then obviously the people will like it, because people do like things which are easily readable. Okay, they do like things which are easily understandable and with a lot more complexity that is hidden from a common users, because we do have a concept of abstraction. In object-oriented programming languages, there is a concept of abstraction. So whole lot of complexity of coding get hidden behind this layer of abstraction. So when we say abstraction is important, another question comes, sir, if abstraction is so important, then why to discuss or to understand a whole lot of complexity that is behind that particular layer? Because we always discuss the concept of abstraction, but in the last, ultimately we jump into the question of code only. So many lines, so many functions, so many different syntaxes. Okay, and all those things are supposed to be taken care while coding. So why not to develop a kind of abstract programming kind of system only, that we are supposed to just give our input. Sir, it is my input. I want this kind of output. Now you only code. Yes, these kind of systems are also available, because kind of expert coding systems are available. Okay, and work is in progress on such systems. As if you remember that smart dispensing machines are available, and those machines are not supposed to code for you. But yes, obviously they are supposed to light burden your work, and those are supposed to give you the kind of things. Those are supposed to take some sort of efforts. So many things are already in market, and for coding also there are some intelligent coding platforms where you give your requirements, they'll code. But obviously that coding not be kind of efficient one, because ultimately a machine coded code will require a kind of AI, and that particular AI will again come from the kind of code that is written for that particular AI. So what quality of AI code you have already incorporated in that particular firmware or hardware, that will guide the direction of actual coding that the particular user wants. So in this way, you are supposed to be very conscious while coding a particular machine. And obviously, if you are not able to code your machine, then how can you code the AI of that machine? So in this way, the conclusion is that take a AI-based machine from an expert, and then you put your work, means throw your work on the face of that machine. And if the related functionalities are incorporated in the AI of that machine, then it will do your work. Okay. So in this way, like you must have heard of MATLAB. So inside MATLAB, kind of embedded C option is there. You can export your C code automatically. Okay. So there are so many things means that you can do. So in this way, it's just a plain simple example that how you can give your requirements to a particular machine or kind of AI, and it will again throw you back with some sort of instructions or the kind of code, the snippet that is required for your particular requirement. Okay, so leave all these things. We are coming back to topic that the layered, first thing, it offers a simplicity. Second thing, organization. So when the organization is good, simplicity is obviously achievable. And from user's point of view, user's view become more easy to interpret, and user feels good that yes, it is so simple, I can learn more. So you can't show him the first complex picture because he'll resist to learn more. Sir, it is too complex, it's not my cup of coffee. Okay, but no, yes, you can handle it. So just to show him this picture, sir, it is like this, it's basic, and now gradually we'll delve into the complexity. That is the approach of teaching or anything, explanation or something. So you are not jumping directly into the ocean of code. You are just simply showing him that, sir, these are the 4-6 steps. And then you are supposed to come over to the binary code or the machine readable code. So now he is coming with you. He is supposed to say, yes, now it's looking fine. Carry on. So here, device drivers. You can see here at the bottom of this particular structure, there is a devices. So obviously device drivers come into picture. They are supposed to manage the kind of devices, and obviously taking the help of some IO control. There is an example written over here: read drive 1 cylinder 72 track 2 sector 10. Okay, so as we do know that the disk is a combination of multiple cylinders. Kind of cylinder, and we have multiple tracks onto it. So if you have multiple tracks and then you have multiples, now how many cylinders? That is again a question of choice. Okay, so we are supposed to consider one cylinder. Okay, then multiple tracks, then multiple sectors. So you are supposed to come onto the actual location where you are supposed to read or write. So the read-write head will come onto that particular location. If you remember, we have discussed the concept of seek. Okay, so seek means it's a hardware kind of mechanism in which we come onto a specific location where we want to read or write, or we want to search for a particular thing. Okay, then you can read, write. So this is a kind of at low-level language instruction, which you can use, because we are discussing the concept of cylinder, tracks, and sectors. It is not discussed normally in high-level languages. Okay, and then you are supposed to put some data into memory at location 1060. So output, device drivers normally outputs low-level hardware-specific commands, because device drivers, again, the kind of low-level utility programs, those are supposed to generate the actual machine-level code. Okay, for hardware controller or for your OS operating system. Now, additionally, the layered file system manages your memory buffers and caches. Okay, because when we are saying that we are supposed to store files, then it can't get complete without help of your buffers and the caches. And why buffers? Again, there is a unsynchronized devices, or the kind of concept of synchronization comes into picture. The speed of devices are different, and that's why you do need a kind of synchronization in terms of buffer or cache. Then buffers hold data in transit and caches hold the frequently used data. You do know very well. Then file system file organization modules, it translates your logical to physical block. We have well discussed about it. We have well debated about it in process management. Then it manages the free space and the disk allocation. This also has already been discussed a lot when we discussed the concept of memory management. Moving forward, the concept of logical file system. So logical file system, we discussed that particular time that set of all logical addresses means logical address space. Okay, when we discussed the concept of processes. Now it is supposed to manage your metadata. Metadata means the data about data. That's the metadata. So for example, process. What is a process? Then you will define the particular characteristics. So these are the different pointers. Those are supposed to be taken care of by this particular process. This is the memory address space that is supposed to governed by that particular process. These are the different kind of child processes. Those are supposed to get generated from that particular process. So what are these details? These details is the metadata of that particular parent process. So when you give data about data, that is metadata. Now translates your file name into file number, handle, location, kind of access, and other things. Again, means what you are telling, sir, this is the file ID, FID. Then it's a handle, means the kind of pointer. It is the location, the actual memory location. Then, sir, this is the different access and rights. Those are supposed to get involved with respect to this particular file. Means the owner can't execute it, but the group can execute it, and kind of all these things. Okay, so all these things are what? Again, the data about that particular file. So data about data, again metadata. So you need to, means logical file system is supposed to maintain the metadata things, and then it is supposed to maintain all these data in a particular structure, that is obviously directory, because you cannot store file within file. So you do need a concept of directory, means folder, and then you are supposed to store your different files according to their specific characteristics in different folders or directories. And obviously when you store the files in different directories, one notion is of manageability, means you need to manage things efficiently. Second thing, you need to cover different access rights. So if you are putting different access rights, means protection comes into picture. Okay, so protection is again important concept that is governed by our logical file system. Now the layering is useful. We have already discussed well and just 2 minutes before about it, that it is useful to handle complexity and the kind of redundancy. Okay, and when you handle the layers, okay, so one, for example, in computer network, so whatever work is done by your presentation layer, that is not supposed to again done by your network layer. So it's what? It's just the lack of redundancy, means you are not repeating the same task at different layers. So layering offers you this thing also, that it simply helps you to identify and remove the redundancy wherever it is present inside your system. Okay, but obviously the other thing, as I told, that whenever you incorporate new features, it never comes free of cost. Okay, so the extra cost comes always with the extra functionalities. So what is the extra cost? That is in terms of overhead. So there might be kind of different kind of complexity. Different kind of complexity means it is not the visualization or the organization. It is the kind of that earlier you had only one option of storing file. Okay, now you have multiple options. Means you can have different locations. For example, take an example of contiguous memory allocation. Contiguous memory allocation asks you to simply start from a particular location, store all the bytes, all the components of a particular process contiguously. Very simple, nothing complex. Okay, you don't need to maintain anything. But there comes the another concept of linked storage. Linked storage means you can use the different distributed parts of memories, and then you can make use of all the distributed components. Those are free but are distributed across your memory space. Okay, so what is the benefit? Means you can utilize all the kind of external fragmented space. Those are distributed across your memory, but you need to maintain a pointer list, because from one location you need to jump onto the very next component. So you need to maintain a pointer. So obviously linked list kind of data structure comes into picture. So here you can see that in first case, in contiguous, you don't need to maintain any separate data structure. But here you are supposed to maintain a separate data structure in terms of linked list of pointers. So overhead is there, but efficiency is also there. So again, a choice of trade-off. Okay, you need to maintain always a choice. You want performance or you want this kind of complexity. So if the complexity is not coming more, but you are having good efficiency, okay, go for that. Fine. Moving forward, file system implementation. We have discussed that what is a file, what is the file system organization, what are the different benefits, why do we need the layered file kind of structure, and then the basic question that all these things are supposed to get governed by what? Means why we are doing this. Ultimately, what is the actual step? So actual step is implementation. How you are supposed to implement your file system. There are different choices, but how you are supposed to implement those concepts in real concept, means in real world. So system calls concept come into picture, because when we say that we are implementing a particular file system, means what? We are asking the machine to work according to our wish. So machine is not a kind of very hi-fi AI packed machine. It is supposed to be kind of dumb machine. Okay, so here, if the machine is kind of a dumb machine, then it is supposed to follow whatever you are throwing onto its face. So here, if you are putting some good commands, means which are not of complex nature, then it is going to read it very fast. Because again, if command complexity is more than the machine is supposed to interpret, it might incorporate some internal interpreter for that particular choice. Then again, if you like, again, a very good example of trade-off, if you have chosen the high level languages for programming a particular OS, okay, or file system implementation, then what in high level languages means for user efficiency, it's good, because user is not supposed to bother about all the internal or the low level details of your file system. He is just simply supposed to give command, okay, kind of memory implementation, okay, I'm going to use this particular system call. Okay, means a kind of command that is pre-built. Pre-built means already stored in the header files or in the libraries of that particular programming language. Now he is going to use a particular function of a particular library of that particular programming language, but work is done. How? Because machine interpreted. Interpreted how? Because there is a kind of assembler or interpreter in between, or like in Java we have in between. So there is a JVM Java machine concept, and there we do have just-in-time compiler, JIT compiler. Okay, so it automatically compiles the internal codes, and there it improves your system's performance. So when we discuss the concept of internal APIs, then we discuss the concept of system file and system call handling. So system call is supposed to get converted into the actual low-level APIs, which are supposed to get practiced by the particular operating system for efficient implementation of your file system inside your system. Okay, so here we are saying that system calls implementation uses the APIs and the on-disk and in-memory structure. What are the on-disk and in-memory structure? Because when we discuss the concept of high-level languages, then user is here, because you don't need to bother about all the low-level commands. He is just supposed to type in English all the things. Okay, but machine burden is more. But if you type or you are able to code in low-level language, machine burden is less. The machine is not supposed to again convert into a low-level language or the machine language. You can directly work at low level. But here the complexity is more at user side. So always a choice of, always a kind of trade-off scenario. Means you need to make a choice whether you want the more complexity at user side or more complexity at device side. And obviously we go for the second choice, because we don't want to make the user's side heavier, because user might be of any particular nature. He might not be very familiar with your technical side components. Okay, so we are well aware about this fact that we are supposed to incorporate high level programming languages, and machine will take care of, because machine is fast enough, okay, good enough for giving a particular kind of response. Now boot control block. Boot control block means what is the booting? You must have heard of POST, power on self-test. Anybody will like to comment on this particular topic? What is POST? Anybody? Power on self-test. Okay, fine. It's a kind of test that is done by the machine. You must have heard of the beeping sound. Okay, there is a particular pattern of beeps. How many beeps, how long beeps, and all these things. Okay, in Morse code also, these kind of things are supposed to get practiced for message or the encrypted kind of transmission. Okay, that is in military and in fast communication systems. Okay, but here when we are discussing the concept of beeps, when you open your system, you power on, and just 2 beeps, two comes. Okay, kind of. It means what? 2 low beeps means system is perfectly fine. Okay, kind of. So these practices are part of POST. Means your system is doing the power on self-test. Means all my components are fine and they are working fine or not. Their related device drivers are up to date or not. Means they are supposed to handle the user's work or not. Okay, so if the user means a device is done and device is over with its post, then obviously it is going to show you the desktop. Now you are means you can just throw your work onto machine, and machine will take care of all the things. Okay, so boot control block is supposed to take care of your booting activity. Booting activity means what? You are supposed to load your OS. Okay, so usually the first block of your volume means whatever volume is having your OS. Normally we do have the C drives in Windows. So C drive in the first block of that particular drive is supposed to get named as boot control block. Then volume control block. Volume control means what kind of volume you do have inside your system. Then how many different blocks and how many there are free blocks, kind of occupied blocks, what are the different sizes, and a whole lot of things. Okay, so you need to maintain the different pointers with respect to each process, that these many different blocks are part of that particular address space. Okay, and likewise for other processes also. So volume is supposed to take control of whole lot of memory that is available, but boot control block is supposed to take care of your booting activity. Moving forward, we have the concept of file system. Wow, file system, again, as we do have the kind of memory. Okay, so when we want to improve, when we want to add on some functionality in terms of memory, we do have the kind of virtual memory. Similar way, when we do want to add on some ease of access or ease of management, then we incorporate the concept of virtual file system. Okay, so file system that is hidden by a virtual layer, so that is virtual file system. So here example is virtual file system on Unix. Okay, so on Unix you do see a particular virtual file system that is supposed to take an object oriented kind of notion to maintain the file system. Could anybody please elaborate the concept of object oriented programming? Anybody? Okay, fine. Let me tell you. Object oriented means you are supposed to. I'm audible? Hello.
Yes, Professor, you're audible.
Okay, thanks. So object oriented means everything is oriented towards objects. Objects. What are the objects? Whatever thing you see in real world, that is an object. Okay. Or you imagine about, means if you are imagining some concept, that is also kind of object. Okay, might be virtual object, imaginary object, but it's an object. So anything that has some sort of properties, some kind of attributes, that is an object. Okay, and when you write your code with respect to that particular object thinking, means you are oriented towards a object kind of approach. So that particular programming style is known as object oriented programming. Now there are different languages those support this particular kind of programming style, and obviously those languages are supposed to termed as object oriented programming languages. So Java, C++, and all whole lot of Python, all these things. Programming languages do support the concept of object oriented, and it is very much useful. Means to maintain the high level concept, the real world concept in programming world. All these things are important. So we'll not go into delve of object oriented things because that is a different subject. Now we have the VFS, virtual file system. So virtual file system, as you can see in figure, the virtual file system interface is there, means a kind of layer that is supposed to hide the underlying complexity. So your file system interface is supposed to throw some commands to VFS. VFS will take care of that. It is supposed to store in disk 1, disk 2, or some means when the command is supposed to put some data or read data from network. Okay, if you are downloading some media from your network, then this particular way is supposed to get utilized, but you don't need to think about it, you don't need to bother about it, VFS will take care of it. Okay, so your file system is not actually working on your network or the kind of disk devices. There is a dedicated layer and it is maintaining all the things, and it is just replying with the suitable responses. Okay, so whenever you add some layer, obviously the layered kind of structure improves the user's view, means it relieves the user from all kind of burden. So similar way, the VFS allows for the system call interface implementation for different file system. Additionally, you can use a different interfaces for same file system. Okay. Additionally, the file system generic operations are possible, and you are also not supposed to bother about the underlying hardware devices. Means what are the different disks and what kind of network you are working on. Okay, because of network properties might be different, ranging from one network to another network. But your file system should be capable enough to work with all kind of networks and other input output devices. And your VF is also responsible to dispatch the right kind of operation for a particular implementation. Means you want to write a particular piece of block, okay, onto a particular third-party storage or the network. Then your VFS is supposed to get familiar with the underlying writing mechanism. Means word by word or block by block, you are supposed to write that character. Then again, the concept of block media transmission and the character based transmission comes into picture. So all these things, and because ultimately whenever you are writing in memory, then input output memory, all these things are attached with your file system, because ultimately anything that will get stored inside your memory will get stored in terms of a file. So VFS is nothing but a virtual kind of file system that is supposed to help you out in a complex situation. Okay guys, so then the next concept of allocation method. When we say that we have discussed the concept of files, it's a system, it's a underlying mechanism, the virtual file system, and its implementation also. Now we have understood everything. But how specifically those are supposed to get stored in a media drive? So allocation comes into picture, and like process, here are the kind of similar choices, because we discussed all these three concepts earlier also with respect to processes. But ultimately processes are what? Programs. Now here we are discussing the same thing, but from a different perspective. Okay. So what is the allocation method? Obviously means how you are supposed to allocate, means how you are supposed to store the things on disk, because ultimately file system means your disk system. So with respect to process, we do discuss the concept of process management in RAM, in physical memory, in primary memory. But with respect to file system, we discussed all the similar kind of concept with respect to disk memory or your secondary memory. That is the only difference. Rest everything means concepts are same, but you need to think differently. You need to discuss all those concepts differently. So here, three types of allocation: contiguous, linked, and indexed. Well debated, but we'll see one by one. Which one is better? Again, it depends. It depends on the choice and the underlying hardware and your context. Means what kind of processes you do need inside your system. Means what kind of programs you do have. Here we will not discuss the concept of process, because we are not talking about RAM. We are not talking about primary memory. We are talking about the secondary or disk memory. That's why everything is program, not process. Okay. Now, contiguous allocation concept. So each file will occupy the contiguous blocks. Quite obvious. Best performance in most cases. Yes, because most cases are simple in nature. You'll wonder that, sir, how it's possible to have the best performance in most cases? Because if I ask you, how many people do actually use or utilize, or means we should not use the word exploit, but how efficiently you do use your system? How people do use even 50% of their system in daily routine life? Very less. Means if you count on fingers, means just 2 or 3%, not more than that. Okay. So whatever system, if you go to market also, you purchase a very hi-fi kind of system. But obviously the question should be your mind, means how efficiently you are supposed to use that machine. If you are not, why you are purchasing that costly means kind of a monster? Because ultimately so power packed system, if it is not getting to utilize, it's a waste of money. Okay, so we are not bothered about the financial constraints of people, but performance is always subjected to the utilization of resources. So when we are saying best performance, then utilization of resources is not the focus. The focus is kind of that how user is experiencing things. Now here, best performance in most cases, here the user's view, that particular perspective is taken care of, because ultimately user should have. And considering the present systems are having terabytes of memory, then obviously there is no major effect of fragmentation, because you are not going to use your system that extreme level, at that particular extreme level that you are supposed to get bothered about the fragmentation and all those kind of things. It means before operating system, have you heard of had you heard about any concept of internal or external fragmentation earlier? No, never. Most of you definitely must never have heard of this external or internal kind of fragmentation. Why? But all of you guys must have been using systems since the last 15 to 20 years at least. Okay, means not system, at least mobile. but we never bother about fragmentation and all these things, because obviously our system, our machine is good enough to take care of all our requirements. But because we have purchased a machine that is over qualified for our kind of requirement. Okay, so that's why, though contiguous allocation is not the best choice, but still it offers best performance in most cases because machines are powerful today. Simple. Why simple? Because you don't need to bother about the pointer allocation and all the pointer management and all those things. Start from a base location and store all the things. Simple concept. Okay. So again, the same concept with respect to process management. You need to choose a base address, and from there you need to maintain a length. Means then base plus length, that is your boundary. Okay. Then what are the different issues? Finding space for the files, knowing the exact file size. Okay. And obviously external fragmentation is possible. Though we are not bothered because of our heavy packed machines, but yes, we cannot take that scenario as a general scenario. So that's why external fragmentation is always there. But when we have the concept of fragmentation, we do have a kind of compaction mechanism also. But yes, you do need to maintain the compaction offline or online. If you are going for online, then it might be time consuming. But if you are going for the offline choice, then your system will be down. Means it will be the downtime. If it is taking 2 minutes or 3 minutes, that will be downtime of your machine. Okay, so some server is there and it is doing kind of offline compaction. So memory is suspended for that particular duration. That is the downtime of that particular server. Okay, guys. So here you can see the contiguous allocation concept, that file is there, start address is there, length is there. So for count file, okay, starting from 0, length is 2. So you can see that 0 length block, then from 0 to 1, 2. So 2 contiguous memory spaces are allocated. Rest chunks are free. Then from 6, you can see F. So F is starting from 6 and again having 2 blocks. So here 2 blocks from 6 and 7. So in this way, all the processes are having contiguous space. All the programs are having contiguous space. Moving forward, the concept of linked allocation. The same thing, but the only difference that you are supposed to taking care of different distributed locations. So we had the drawback of fragmentation in contiguous. How to remove that drawback? You are just supposed to incorporate the concept of pointer. So you maintain the list of pointers, and then you can point from one location to another to another. So file, start, and end. So at start location, there is the address. It is not the final, means your base address. It is your starting address. You can call it a kind of base address, yes, because it is the starting address, but it is not like similar to the earlier one where from base you are supposed to store contiguously. Here you came at 9, then again there is a second base address with respect to this particular location. Now here, but yes, don't get confused. You simply remember only one thing, that whatever is the starting address, that is kind of base address, but from there you need to jump onto another address. No consecutive elements will be there. Okay. They might be, means it is not always necessary. For example, you can see here at 9, after 9, there is a contiguous block that is at 10. But it is not part of this particular sequence, because after 9, your program's second part is stored at 16. Okay. So you came from 9 to 16. Then from here, you came to 1. Then from here, you came to 2 and so on. So in this way, you can accept. And at the last location, it is your 25th. So at 25th, if you want to jump directly, then you can see here that it is the -1 value here. Means kind of sentinel is there. It is not always necessary you need to put 1. Means it will get taken care. It will be taken care by your system programmer. That will define. Means you must have heard of many constant kind of things. Okay. So if you are defining some nil pointer, so nil pointer kind of concept of what value you are considering as nil. Okay, it's not your choice. If you are writing your own system program, then obviously it's your choice. Okay, so in linked allocation, the efficiency is improved by clustering the blocks into groups, but increases the internal fragmentation. Okay, because you are using more memory spaces, those are distributed. And why you are coming for a linked allocation choice? Because your memory space is not contiguous. And if you are linked allocation method you are using, then you do know that memory is fragmented. If memory is fragmented, means you are supposed to put part of your data in one block, part of your data in second distributed block. So in this way, in this program allocation, you did everything well. Okay. But suppose if after a moment you removed this particular page only of this particular process that is supposed to take care of all these blocks. Okay. So the page came out. Sorry, it is not your page because it is not your main memory. So here you are supposed to take 1 minute. Here we can see. Where did it go? So here, yes. So earlier, yeah. Yes, here. See here. Here all the components are consecutive in nature. Okay, so if all the components are consecutive, then you are not bothered about the kind of choices because everything is contiguous. Then everything whatever is available, that is fine. Okay. Now if these things are not contiguous, then it's this kind of choice, linked allocation choice. So linked allocation choice here. Now after a moment, this particular block means this particular page. I'm saying page here, but it is not page, it's frame. Okay. So this particular frame, because with respect to disk, we do call the concept of frame. Like we don't say that it's a process in disk space. It's a program in disk space. Similar way, we don't call that it's a page. We call that it's a frame. So same thing, same piece of software or the same piece of program, but ultimately we are supposed to maintain a particular you can say terminology, because if we use the same term for your physical memory allocation also, for your disk memory allocation also, then it will become kind of complex. You'll get confused, user will get confused. Again, we need to maintain the simplicity of user's view. So here, if you take this particular frame and you swap in means you are swapping in from disk to RAM. Now this particular block is free here. Okay. Now if this particular block is free, consider normally there is a copy that is copied from disk to RAM, but we are imagining, because I'm trying to give you an example where a particular link is broken from 16 to 1. This link will change. Now 16 will point to some other frame or the location, because that frame is supposed to have a secondary suitable copy that is available for choice. So you just simply imagine, because normally whenever we store something from disk to RAM, we don't erase the existing copy. We don't like we have discussed the concept of copy and what was that? Copy and move. So I also asked you guys that what is the difference between copy and move. So when we move something, the original copy is moved, but in copy there is another copy that is formed, and now you have two copies. So similar way, when you move, means when you swap in, when you move some content from disk to main memory, you do make a copy and then you put in RAM. Okay, but it is not like that you are supposed to not take care of the original copy. And again, at your disk allocation and the disk maintenance means that particular module will take care that how many copies you are supposed to maintain inside your system. Again, not a thumb rule that you need to maintain a single copy only. If your system is a kind of critical importance and you do need to maintain all kind of sensitive information, then multiple copies of the same kind of information might be available. Okay, so in that case, redundancy will be more, but obviously your system storage is not efficiently used. Redundancy is more, but your system is secure. Means your information is much secure, because if one copy gets corrupted, other copies are available. So in this way, you just imagine what I'm trying to say. If it is the linked list, you came from this starting address, you came at here, it is the base address, then from here to another, means it is the information 1, then the pointer 13 sent you, it is not 13, I think it is 16, it is wrong here. Okay, then 16, from here, then you went here, then from here, then you went here. No, it is some other information. 6, then from 6 it came at 2. Okay, they must have taken some other analogy. I don't understand why they have took here 6 here. Okay, you just simply understand I'm not going to delve into this unnecessary discussion. According to a normal understanding, there are two components. One thing, data component. Second is the pointer component, means the address component. Okay. So when you jump onto a specific location, you are supposed to have a data component that is one here, you can see. Okay. And then you are supposed to use the address component that will guide you to the second location. From there, you again fetch the data component and use the pointer or the address component to move to third location, then fourth location, then fifth location, and in the last you will have some sort of sentinel or the nil pointer that will tell you that, sir, it's the end. Okay, so in this way, linked allocation means, if you guys must have heard of linked list, then it is similar to it. Okay, why they have used here different sort of notion, that I'll see it. Then there is a concept of reliability. So when we discuss the concept of reliability, then reliability might be a problem. Could anyone please tell me why reliability might be a problem in linked allocation, not in contiguous allocation? Anyone?
We don't know if there's a problem with the address variable, we may not be able to get to the next.
Your voice is not audible. Could you please speak louder?
Hello? Is that fine?
Yeah, Shweta.
If there's something wrong with the address variable, we might not be able to get to the next point.
Mm-hmm.
And I don't think there's those variables are not stored anywhere else. So if this doesn't work, we won't know how to get to the next point.
Yes. Fine. It's completely right, because there is a notion of dangling pointers, means the pointers are pointing towards nowhere. Okay, so if the intermediate pointers do get big, okay, if some sort of means any sort of event may happen inside your system, and they may means kind of situation might occur where you don't know where is the next location address, and obviously if you don't know the respective address, then how you'll fetch the respective content. So in this way, problem is there. So those pointers are dangerous because they may lead to some very random location, because pointer means some kind of garbage value might be there if you have not used the right kind of memory deallocation mechanism. Okay, so memory deallocation mechanism will take care of these dangling pointers also. So in linked allocation, as you are using multiple pointers, because your memory might be full of so many external fragmented space, so that's why you are supposed to take care of all those spaces. So lots of pointers are supposed to get used. But if any single of them, or if a single of them is pointing towards a wrong location, then all forward location access is not possible, and you are totally moved into a different direction where you might lead to some very random content. Means you are not going to get very much related with your original content. So in this way, reliability of your system or your program is at stake. Means it's a concern. Means if you want to move to linked allocation, be cautious that your pointer handling is good enough. If pointer handling is not good enough, then don't move for a linked allocation choice. Then locating a block can take many input outputs and disk seeks. Disk seeks, as I told you, that seeking disk is an operation, and it may take multiple input output, because again you are supposed to store data at different random locations, and you do need to locate a particular block also. So multiple seeking is required. Means your read write head locations should move very frequently, because from one location, one of your program location might be at the very start of your memory, and another location might be at the very end of your memory. So in this way, means disk head need to the disk read write head is supposed to move lot in comparison to contiguous. So lot more hardware activity, and obviously the power consumption. Okay. It is not related to this subject, but yes, when your disk head performs multiple activities in terms of movement, then obviously a lot more power is at stake. So here your power is more, consumption is more. So that's why your system power specification criteria, that is not good enough. It means if power is also one of the metrics that is considered for system performance, then your system performance is not good. Okay. So in linked allocation, each file is a linked list of blocks. File ends with nil pointers, no external fragmentation. All are very basic points. Then each block contains a pointer to next blocks. Quite obvious. No compaction because no fragmentation. Okay. Then free space management system. You need to maintain the free space. That is the only requirement. Okay. Because if memory is fragmented, then you need to take care of all the free blocks. Then only you can store your data. So everything you can see that block is what inside a linked allocation. A block is a series of pointers. There is a base pointer and then there is a series of pointers. Okay. So then the last allocation concept, that is indexed allocation. So in indexed allocation, we do have the concept of indexes. So if you multiple indices are there means in your systems, or there is a single index in your system, then using that particular index means it will depend on the choice of system, how large the system is. And indexed allocation will use a particular file for indexing purposes, and that particular file will guide towards the base addresses of different programs. So here you can see the index table. What is the logical view? Logical view means kind of a user view. Normally users think that there will be a pointer like at the first page, at the index page of your book. From that particular page, you are supposed to get a page number, and then you are supposed to jump onto the exact page number. Okay, so that is the kind of logical view. But in actual implementation, it is like this, that at file, you are supposed to maintain an index block, and that block will guide you to a particular location. Then from there, you can jump onto different locations. So in this way, you can maintain multiple kind of pointers. Yes, you need to maintain pointers. So you can see that when we choose the index concept, then what is the benefit of index over that linked allocation? That in this particular type, when you discuss the concept of linked allocation, then in linked allocation, you are supposed to move means one by one, because in linked list, what we do have in linked list, you can't have the random access. Means if you want to move on to the fourth block, you can't. Why? Because in random access, you are supposed to directly jump onto the specific location, but that is not possible in linked list. Yes, you can make your linked list to take you to exactly particular location that is suitable for handling right now. But that needs a specific pointer. That is means if you heard of modified linked lists. Okay. So then in modified linked list implementation, you may have this sort of concept where you can have some special pointers, or a doubly linked list where you can move into both directions kind of things. So doubly linked list, again, a specific and special type of linked list. So you can modify or you can redesign your own linked list. Then it's fine. Then you can have some random pointers, means multiple pointers available. Those may take you to a specific location. So that particular implementation is again kind of costly in terms of space, because you do need to maintain some extra pointers. So again, the concept of trade-off, that how you are supposed to maintain that particular view inside your memory. What is the cost that you are willing to put at a stake? Okay, so if your cost is more, then don't go that for that particular choice. And again, we are going to discuss the concept of trade-off here when we'll discuss the concept of pros and cons. So in terms of pros, with respect to contiguous allocation, it is the excellent, and the means it is excellent because of its simplicity, and read performance is really good, because normally everything is in a contiguous space. So when you read something, you don't need to jump onto other locations. So obviously machine will read very fast. Okay, we are not talking about here the user read. Okay, it is the machine read. Machine read means machine is fetching something from that particular location. And it is easy to implement, supports both type of file accesses, which is sequential and direct. And con means the disk is fragmented because external fragmentation is there, obviously. Okay, and difficult to increase the size of the file. Why difficult to increase the size of the file? Anyone? Hello.
Could you repeat
Okay.
the question, Professor? Sorry.
Sorry.
Could you repeat the question, please?
Why it is difficult to increase the size of file in contiguous memory allocation?
If a block that large needs to be available.
Yes. Fine. Because if the sufficiently large block is not available, then how can you store that particular part? Okay. So here because at random means there might be some random blocks. So sufficiently large block is not available, then you cannot store that particular process or program there. Okay, so it's a difficulty. Now linked allocation. What are the pros? No external fragmentation because we are using the concept of pointers. Okay, in linked list allocation, directory entry only comprises of the starting block address. As I I have already shown you, means when we discussed the concept of block, there was a starting block address. Okay, then there is a list of pointer. Then it is more flexible because we can quickly increase the size of file. How we can quickly increase? Because in contrast to your contiguous allocation, multiple memory means memory is available inside your system because memory is of large capacity today. But the only point that is it available in a contiguous fashion? No. In contiguous space, we don't have sufficient memory normally. Okay, but distributed memory is always present. So that's why it's easy to increase the size of file in linked allocation. Now, what are the cons? That it doesn't support the direct access or the random access normally. Why? Because again, we need to modify our basic linked list structure. Second, that in linked list allocation, we need to traverse each block. So means again the sequential kind of access. So if we are sequential access not with respect to memory, okay, totally understand this point. Sequential access with respect to linked list parts. You cannot jump onto the third block of linked list. You need to start from first block, then second, then third. That's why. Okay. Third one, wrong pointer handling may corrupt your files because if you are moved in a different direction, you are gone. Okay. And last point, it needs extra space for pointer handling. Quite obvious. So lastly, the indexed. So it solves the problem of external fragmentation and offers you direct access also. Okay. So in this way, you get the best of both worlds, kind of. Then what are the different drawbacks? Then pointer overhead is more. Why pointer overhead is more? Because you are supposed to maintain the index page. Okay, that is the burden. And obviously, if your program size is small, means suppose if your program is very small, will you go for indexed allocation? Though the benefits are more in comparison to contiguous or linked allocation, but maintaining index, creating index, then it will add on complexity on space also and time also. So that's why we normally don't go for the index creation for small files. Okay. And again, the same point that incorrect indexing means incorrect pointer handling may lead to chaos. Means you'll move to a totally different location. So we have understood the concept of file system, its handling and implementation. Now the second concept means the second module kind of thing, that directory implementation. When we discuss the concept of directory, then there is a basic implementation, that is linear list implementation or the hash table implementation. Linear list implementation again kind of thing means pointers is there in linked list implementation is there. So wherever there is a linked list implementation, you are sequentially need to move block by block. So it is simple to program, but it is time consuming. Okay, because again, why time consuming? Because don't have direct access kind of thing. Okay, so here linear search time will be there and could keep orderly alphabetically. Means you are supposed to use the B+3 kind of concept, or you are supposed to maintain the kind of alphabetic order for arranging your files, means for the ease of access. Okay, that's why. Now hash table implementation, hash table is a kind of indexed allocation. Means when we when we discussed the concept of file system implementation, we discussed the concept of index. So hash is kind of same thing. Means inside hash function is a one-way function. One-way function means you cannot reverse the direction of its functioning. So here, if you have put something, for example, you have a particular key and you have generated the hash code, but you cannot generate the key from hash code. Okay, so it is one way. Means from key you can generate hash code, but from hash code you cannot generate key. So hash table is a linked list with hash data structure. So it decreases the directory search time. Okay, because in order of 1, you'll directly jump onto the base address. In indexed searching or in indexed memory allocation, what is the order of complexity? It is order of 1, means constant. You are just supposed to go to the paged allocation, and that particular paged allocation, you are supposed to search for a specific page number in your book, and you are directly supposed to jump onto the specific page number in that particular book. Similar way, here you are supposed to search your index and you are supposed to jump onto a specific base address. Is there any collision? situation, yes, there might be some collision situation, but again, it will depend on the implementation of hash. How efficient hash implementation you have taken into consideration. That less, that means lesser number of collisions will be there. Collision means a kind of situation where two files names or the two key values are producing the same hash. So if two keys are producing, here what is the key? Here key means what you are feeding into the hash. You are feeding the file name that I want to search this file. And what is the output of hash function? Hash function will send you the base address of that particular file. Because ultimately we want to store file now or search file. So collision means that two file names are producing the same location. And it is only good if the entries are fixed. Means for the very long chained or the overflow kind of situation, it's means chained overflow situation. It's a different concept. First, let me explain that if entries are more, then what will be? If entries are more, then again you need your index size. Like we discussed the concept of page table. We discussed the concept of page table. So page table, and we have already discussed the concept of TLB also, translation left side buffer. So if number of entries are more in TLB or in page table, then what is the benefit of page table? Because earlier you were spending your time in searching frame in hard disk. Okay, now you are searching your time. You are spending your time in searching for a specific entry in page table. So if page table is too large, search time will be more. Similar way, if entries are more, your index length will be more. So more time will get spent in index searching only. So that's why indexes should be of moderate size, means not very less, because again you will not create index for that particular program, and not very large. Okay. Second thing, if your index is large and you want to, means your number of pages or the frames are very high, okay, and you want to maintain an indexed kind of allocation, then there is a choice that you are supposed to maintain the chained overflow method. So if you have heard of the hash function in data structure, then you must have heard of the chained allocation also. Okay, there one block points to another block of pointer, then another block contains the another block of pointer. So in this way, you don't need to search the whole lot of space down. Okay, you are supposed to move into the left to right direction, and you are supposed to follow a particular stream of pointers. You don't need to, means the hash value, your file name will send you the first block address, then that block address will keep chain of all the other multiple different pointer blocks. Okay, don't think about this, because we are not discussing data structure here, we are discussing the concept of operating system. So you just simply understand that there are two choices, kind of hash table based implementation and the simple linked list based implementation. Okay, so now there is a last module, that is a concept of file sharing. So file sharing is what? Means we are supposed to share the files. Very simple. This is quite obvious. I think everything you know. FTP is well known. When you want to transfer large size files, and then obviously you are go for the FTP protocol, file transfer protocol. If a peer-to-peer network is there, then you are supposed to go for the peer-to-peer based sharing. Removable storage, media based sharing. Every day we do like that only. Okay, and online file sharing services, obviously, because in daily need, we every day use the cloud services. Okay, so online services are also there. So anybody has any sort of question? Okay, because I think this file sharing is kind of very common topic. Okay, and when we have multiple users or the various locations, because might be the case that the same user is using multiple programs from various locations, and that particular user wants to maintain the same copy of each of the data. Okay, so then also you are supposed to share your files. Okay, like of sync mechanism you must have heard of. Okay, same piece of code or same account logging you want to maintain in your iPad also, in your phone also, in your laptop also, in your server also. Okay, so Microsoft sync mechanism is there. So same kind of thing. Okay, so anybody has any sort of question, then you may ask, because it's the last slide here. Any doubt with respect to peer-to-peer or something, anything? Okay, give me an example of peer-to-peer network. Anyone? Am I audible? Hello. Hello. Archit, Shweta, am I audible?
I think so, Professor. I'm in the hostel and the Wi-Fi is a little patchy here.
Okay. No issue. Fine then. The recording is there. You can fetch the contents from there. And peer-to-peer network, think about it. Okay. When all the parties are of similar status. Okay. Then kind of WhatsApp group. Okay. So peer-to-peer network. What is the concept? Think on to it. These are important concepts. Okay. Those are not part of, means in OS also we can discuss under the category of distributed operating system. Okay. There are different distributed parties which are equal in power and nature. Then it's a kind of peer-to-peer network. Okay. So fine then. I'm going to close this session. Thanks for your time.